Hello everyone, welcome to Database Management. This is week 2. Hope you all have successfully installed the software and read through the introduction section of the textbook. And this week, we're going to go deeper and broader into database structure as well as some of the key concepts throughout the database management. Today, we're going to focus on Chapter 2, ensuring your database structure is sound. This is the foundation for all the following chapters, and it is very important that you read through the textbook very carefully, as well as understand all the concepts within this presentation. And people mentioned why the database structure is so important. And sometimes I'm just a user and the database structure is already there. I just need to pull the data from the database. But a basic understanding and big picture view of good features of database structure will enable a much easier learning process of SQL. And sometimes you are right, you are just a user and the database structure is already created. But a better understanding of the big picture of the good practice will actually enable you to learn faster and better. And database users will avoid common mistakes when implement SQL in their daily work. And oftentimes, even for database users, you are going to create your own database with a few tables within that database. And those tables usually are actually created from other more fundamental tables. So get a good understanding of what will be a good database structure will help you a lot in your daily work. And database users can also figure out areas of improvement when he or she spots a bad design in the current used database structure and then provide feedback to database management administrators for a better performance and a better logic. And usually the database in a corporate environment, the database administrators are separated from the database users. And sometimes as a database user, which will very likely for a business analyst person to be part of the database user community, it is very important to understand not only how to use the tables, but as well as how to design a good database structures. So some of the good practice are actually very simple in the database structure practice. The first one is related to fine-tuning of the fields. And last week we mentioned the fields is also called columns or attributes in a table. Table is a very fundamental structure, and fields is a column of a table. And every column or every field has a name. And first of all, make sure the field name is carefully chosen. That's the first step when you create a table. And sometimes it is very important piece. And for example, you have to use a field name that is very descriptive and meaningful for everyone in the organization. And very likely you are not the only one for the table you created to use, and somebody else is going to use it. And remember to choose a good name for it, so everyone knows exactly what it is when they look at the field name. Use clear and unambiguous field name and avoid acronym or abbreviations, as people are going to misunderstand it if you just use the abbreviation. Make sure the field names is only referring to one characteristic. That is, actually, in the later discussion, one field only contains one characteristic for that particular subject in the table. In the SQL standard, the field name begins with letter and contains only letters, numbers, and a score. And another good practice is use singular form for field names. And for any of the field, you just need to use a singular form of the name you want to use it. So those are the common practice when you try to name the field in a table. For the field itself, in addition to the name, there are a few other good properties that you need to keep in mind. That is related to the structure of the field. First of all, one field represents a specific characteristic of the subject of the table, and one field contains only a single value, and one field appears only once in the entire database. That is, we do not want to duplicate data across different tables. And there's one exception is unless a field is used to establish a relationship between two tables, and the field does not store the result of a calculation or concatenation. That means database is not like Excel. So in Excel, you can actually put a formula to combine two or more columns. And once you change one field, and then the calculate field is going to be updated automatically. In database, that is not the case. So if you are using some calculation and the fields only record the result and not the relationship, which means once you change some of the data in the corresponding dependent columns, and this calculated column is not going to be updated, so that can cause a data integrity problem. So please do not store results of a calculation or concatenation for a field. And there are some kind of like common problems in when one or more of the properties are violated. So here are some examples. Multiple part of fields. Okay, that is one field with multiple characteristic problems. Like for example, for a particular column or field, ask you the following two questions. Can I take the current value of this field and break it down into smaller, more distinct parts? First question. Second question is, will I have problems extracting a specific piece of information because it is buried in a field containing other information? So ask yourself those two questions. For any of the columns, you are in doubt whether that field contains multiple parts. If answer to any of the above questions is yes, then it is a multiple parts field, and we need to break down into smaller pieces. There is one example, like street address. In particular table, there is one column called street address, right here. And it is a multiple part field, okay? Because it can be broken down into smaller pieces. It can be, we can have the street address, city, state, zip code. Can be totally broken down. And when you ask the question, can I find all the customers in Washington, for example? Based on this field, no, you cannot. Because Washington is part of the overall street address, and this specific piece of information is buried in that field. You cannot do that. Or can I order customers by zip code from smallest to the largest? The answer is no, you cannot, because zip code is part of the whole address. You cannot separate them easily. And but we can break that into smaller pieces. So this is one example of one field contains multiple parts. And a solution to that is we can break it up into 4 pieces. The customer address, customer city, customer state, and customer zip. So by doing that, actually we can answer both questions with a query, and it is a much better design. And the user can extract more useful information from this kind of like multiple columns or multiple fields instead of a multiple part field. One field with multiple part. That's bad. And multiple fields which each field contains one piece of information. That is good. So this is one example of bad and good design. Another one is actually more subtle. That is resolve a multiple valued fields. That is, one field contains more than one value. And you can actually spot those kind of problems right away. Data stored in a field contains separators like comma, semicolon, etc. If it contains those, very likely it has multiple values because that's a separation of multiple values. It is an indication of many-to-many relationship, and there are better ways than put everything in a kind of multi-valued field. It is actually through an intermediate linking table. So in this particular example, the pilot table, it contains pilot ID, pilot's last name, first name, here date, as well as certification, which means what kind of airplanes the pilot can fly. So for example, the first one, first pilot, he or she can fly 727, 737, 757, and MD-80. So, but this column is a multiple value field. Okay, there are different kind of certification for each different pilot. It is a many-to-many relationship, which means for each pilot, it can have he can has multiple certification, and for each certification, like 737, it actually associates to different kind of pilots. So that is actually a bad design because, for example, if I want to return the list of pilots that who can fly 737 from this table, it's not an easy task because this multiple value problems. To solve that problem, what we can do is actually create an intermediate linking table. The linking table is like that. We separate the pilot and certification. We're going to have a pilot table, which includes all the information for the pilot. And also we're going to have a certification table, which contains different description of the certification. Then we have an intermediate linking table, which is going to link the pilot ID and certification ID in a kind of like in a separate table. In this particular one, for example, the pilot ID 25100, he has 3 different kind of certification, and it corresponding to 3 lines within that table. Okay, and those 3 is actually 727, 737, 757, etc., and etc. So actually 1, 2, 3, 4 different kind of certifications. By doing that, we separated the pilot and certification, and they are linked by a linking table. By doing that, we can easily return the list of pilot who can fly, for example, 737. And we can return pilot who can fly both 737 and 757. So once we have the linking table, we can answer much more questions. So this is one example of bad design. We have a field which has multiple values, and this is a good design where multiple values actually are resolved by using a intermediate linking table. Okay, now let's go to the table piece, the fine-tuning of the tables. We just finished the fine-tuning of fields. For tables, very similarly, first of all, make sure the table name is carefully chosen. The table name has to be unique, descriptive, accurate, and ambiguous name for each table. Avoid generic names such as file, record, or table in table names. Avoid the acronym and abbreviation in the table name as well, with the same reason I just mentioned. And also using plurals form for the table names. And that's actually a convention. Whenever you see plurals, you know it's a table. Whenever you see a singular, you know it is a field. That is very helpful. Once you make that kind of habit, it will help you a lot to distinguish what is a field and what is a table, especially in a PowerPoint situation. And also we need to ensure a sound table structure. One table represents a single subject, and each table contains a primary key, and no multiple part or multi-valued fields in any tables, no calculated fields in any tables, no unnecessary duplicate fields in any tables. That's very similar to the fields property, but just to make sure when you create a table, you need those fields to be a good practice. One common mistake or one common kind of like easy to make mistake is actually have unnecessary duplications in different tables. And sometimes unnecessary duplicated fields are included in tables with one-to-one or one-to-many relationship just for convenience. For example, you have employee ID, which is the primary key in your original table, and then from the employee ID, you can get the employee's last name, employee's first name, etc. And there's another table which actually has employee ID, then it is everything you know. You do not need to have the employee's last name or first name into the new table because those are unnecessary duplicate fields. Once you have unnecessary duplicate fields, the consequence is actually very huge. It may introduce inconsistent data. For example, you must ensure any duplicated fields are updated once the source data has changed, which are not easy to track. And for example, in our employee table, we just mentioned employee ID is unique, and the employee name actually can be changed. For example, when a female employee gets married, she may want to use her husband's last name. And if you have duplicate last name field or columns in other tables, you have to make sure, in addition to the employee table where the employee ID as the primary key that is changed, and in other tables, last name you have to change the last name as well. In most cases, there's no automatic way to update those duplicate tables and duplicated columns in other tables, which actually create inconsistent data. For field with many-to-many relationship, we need to use a linking table to solve the unnecessary duplicate fields. And the only exception of duplicate fields are cases These fields are used to establish relationship between tables, and sometimes those are the foreign key in a particular table. Okay, we just mentioned the primary key. And what is primary key? A simple primary key, or just primary key, PK, is a field that uniquely identifies each record in a table. A composite primary key, or CPK, is a group of fields that uniquely identify each record in a table. So in a CPK case, there are multiple fields, like 2, 3, or more fields are combined together to uniquely identify each record in the table. So for every table, you should have a primary key. And it is for identification purpose. And in a table, to identify each row or record, you need a primary key. And there are additional features for primary key or composite primary key. It must contain unique values because it is used to identify each and every record, so it cannot have duplicate values among different records. So it must contain unique values, and it cannot contain unknown values. So like null null, which means not null, is not permitted for primary key, and it cannot be optional. So primary key must not be optional. And the value should not be modified unless you have a truly compelling reason to do so. And when there's no primary key or composite primary key, we can add an artificial primary key to the table. And sometimes, in most of the cases, when a table is created, it is going to, if no primary key is identified, it's going to automatically add a column that uniquely identified each record or each row in the table as a primary key. Very important concept. And for foreign key that is in a particular table, it has a column. That column is the primary key for other tables, and that's called a primary a foreign key for that table. And in most cases, the foreign key is for establish relationship between different tables. Okay, so in last week, we actually mentioned the one-to-one relationship, one-to-many relationship, and many-to-many relationship. And we can use the following three kind of diagram to clearly indicate what is one-to-one, what is one-to-many, and what is many-to-many. When we have many-to-many relationship, we're using a linking table to link two different kind of tables. Okay, now let's go to another interesting problem, which is called establishing a deletion rule. And some of you may think, well, delete a row of a table, that's simple, you just delete it. It is simple when there's only one table. When you have two tables that are kind of linked together by a certain fashion, when you delete one record in one table, it is going to have a consequence on the other table. So a deletion rule actually dictates what happens when a user makes a request to delete a record in a primary table of a one-to-one relationship or in the table on the one side of the one-to-many relationship. And this is actually a two different kind of deletion rules we can use when we are at the primary table on the one-to-one relationship or the one side of the one-to-many relationship. The first one is restricted deletion rule. Actually, it does not allow you to delete the requested record when there are related records in the subordinate table of a one-to-one relationship or in the table on the many side of the one-to-many relationship. So basically, to delete a one row, one record in the primary table, you have to first delete any the subordinate tables rows, the record that actually link to that particular record in the primary table, or delete all the many side of the table, the records. Once they're deleted, then you can delete it, the record in the primary table. And then there's another rule is called cascade deletion rule. This is a little bit dangerous, kind of like deleting the record on the one side of the relationship causes the system to automatically delete any related record in the subordinate table of a one-to-one relationship or in the table on the many side of the one-to-many relationship, which means once you delete one record in the primary table, there could be multiple lines, multiple records could be deleted in the subordinate table or the many side of the one-to-many relationship. So the different kind of software has different implementations, but those are the two major deletion rules that we see. Now let's discuss a little bit about participation. What is participation? That is when you have two tables that are linked together by some fashion. It's kind of like their relationship. That's called participation. But there are two types of participation. That is when you establish a relationship between a pair of tables. Each table can participate differently. It can be mandatory participation, which means at least one record must exist in this table before you can enter any record into the other table. The mandatory is, I can give you an example of mandatory. For example, there's one table called employee and one table called department. And we can assign employee with a particular department only if the department in the department table it has that department number. Then the department has a mandatory participation. That is like you cannot assign an employee to a department number that is not part of the department table. So the department is mandatory. Optional is there's no requirement for any record to exist in this table before you enter any record in the other table. So for example, the employee table can be optional and the department table is mandatory. So this is one example. And in addition to the type of participation, there's also degrees of participation. The degrees of participation is the minimum and the maximum number of records in one table that can be related to a single record in the other table. It's kind of like simple in a way for one-to-one relationship. Both the minimum and the maximum are one because for those two tables, it is one-to-one related to each other. For one-to-many relationship, for the one side, both the minimum and maximum are one. That is because there's only one record for one record in the many table. But for the many side, minimum is 0 and the maximum is infinity. But sometimes it is limited by a specific number due to business applications. For example, we can have a class. For any class, like our class 526, and it is at the many side of the table, so it can has many record of students, but we have a limit in number of students to be at most like 30, which means it is one-to-many relationship and the class table is in the many side, but it has a limit number of students can be enrolled in a class. So that's one example of the maximum is not infinity, but it's some limited number. That's pretty much all the details that is covered in Chapter 2. And it's a lot of content, and please remember, carefully read through the textbook as well as understand exactly what I mentioned in this PowerPoint deck. Chapter 3 is a concise history of SQL. It is an easy and interesting reading. Please read through this chapter by yourself. Okay, now it's homework. For this week, we have a homework. So basically for chapter 2, you read through the textbook and answer those 4 questions. And for chapter 3, read through and answer this 1 question. Remember, for those questions, try to answer the following questions using your own language. Please do not copy and paste from textbook or the PowerPoint deck to answer these questions, and understand the content and then try to write your own answer for those questions. To submit your homework, submit a PDF or Word file to the Homework 2 Dropbox through eCollege. Thanks. Have a good week.